In this video, we're going to look at how to calculate values in more complicated circuits, especially when we have capacitors involved. In this case, we're being asked to find the value of R1. However, we need to calculate our capacitors first so that they make one equivalent capacitor. We're going to begin with C4 and C5, as they are both in parallel, and we want to make them one equivalent resistor so that we can make our circuit a little bit easier for us to work with. So our formula will be C equivalent 1 will equal C4 plus C5, which equals 50 plus 174, which gives us a total of 224. Therefore, our first equivalent capacitor is valued at 224 microfarads. This will change our circuit, so our circuit will now look like this. In our new circuit, we need to work on C1, C2 and C3 using the same formula. However, this time we're going to write it this way. C equivalent 2 will equal C1 plus C2 plus C3, which will equal 200 plus 300 plus 193, which gives us a total of 693. Therefore, our second equivalent resistor is valued at 693 microfarads. Again, this will change our circuit. Our circuit will now look like this. Now we have two capacitors in series. Again, we want one capacitor, so we need to calculate both of these down. This time we're going to use this formula. C equivalent 3 is going to equal 1 over C equivalent 2 plus 1 over C equivalent 1. This will equal 1 over 224 plus 1 over 693. When we work that out, that's going to give us 1 over 0.00446 plus 0.00144, which gives us 1 over 0.0059, which gives us a total of 169.5. Therefore, our last capacitor is now valued at 169.5 microfarads. This now brings our circuit down to look like this. Now that we have this final circuit, we have our value for time and we have our value for our final capacitor. We can use our formula T equals R times C. If we transpose that equation, we will end up with R equals T divided by C. And if we substitute in our values, we will end up with 1.695 divided by 0.000165, because remembering we're dealing with microfarads, so we have to change them so that we have compatible numbers. That will equal 10,000, which we can say is also 10k ohms, because we're dealing with resistance now. So R1 equals 10k ohms. As always, whenever we are working on our circuits, we must always write down the formula If you transpose your formulas, write down your transpositions, and show all of your working, that is how you calculate more complicated circuits with regards to capacitance.